So one thing that leads to a lot of confusion is that in chemistry, sometimes both the Gibbs free energy and the Helmholtz free energy are called free energies. So what's the difference between the two? So write this down. F is at constant T and V. G is at constant T and P. And what leads to confusion is that they are both called sometimes free energies. So the next time you pick up a chemistry textbook and it's talking about free energies, know that they are not free energies. The only part of that entire equation that is free is TS. Get it? That's the automatic energy that moves in because it depends on the temperature of the environment that you get for free. But both F and G are not free energy. Got it? Okay, good. So now, do some math, which is going to be awesome. So I'm going to do them side by side. So everybody make a line in the middle. We're going to do Helmholtz free energy on this side with red. Okay. And then the Gibbs free energy on this side. Helmholtz energy was defined as what? Good. And Gibbs free energy was defined as? Yeah, true. What can I just call it that? You're right. It should be H minus TS. So you guys can see the similarities. Okay. I am also going to tell you that F is a function of T, V, and N. And G is a function of T, P, and N. Isn't that what this says? Okay, and then reminding you guys of these things. So when we were doing these derivations the other day, do you guys remember us doing these derivations? How many steps did we have? So I'm going to stick with the 3 steps that we had, right? It's just going to be slightly differently done. Are we ready for this? Okay. So let's start at this step. I'm going to do Helmholtz free energy first. So the 3 steps I'm going to use. Step 1, keep F constant. Step 2, keep T constant. And step 3, keep N constant. So my total delta V of my system, this is volume. Delta V first step, delta V second step, delta V third step. I'm allowed to do that, right? I can pick any variable I want, and I pick the one that I know it's going to be constant in this situation. Okay, so that's my first step. Doing it on this side for the Gibbs free energy, what can I do? Keep G constant. Step 1. Keep T constant. Step 2. Keep N constant. Step 3. And in this case, may I write delta P total as delta P1 plus delta P2 plus delta P3? So far, so good? May I multiply and divide at will? That's math allows me to do that. Okay, so then I am going to choose to do this. Let me do this one first, and then we'll come to the other one. Let's do this one first. So I will have delta V equal, actually, can I just write them now as these for small changes? I should be careful. These are all U's. Oh, sorry, V's. Don't confuse them with U's. If I'm not careful, sometimes I mess this up. So this is dV1, dV2, dV3. So what were my three steps? F, T, and N were constant. So may I rewrite this as dF over dF for step 1, dt over dt for step 2, and dN over dN for step 3. Which implies I can write this as partial V over partial F dF plus partial V over partial T dt plus partial V3 over partial N for dN. Oh, I don't have to have D3 in here. V3 in here. Sorry. Does that make sense how I can get rid of 1, 2, 3 now? Is that clear? And why does it just become V? Because that's the only thing that's happening in that step. So I don't have to keep that step number with it. Okay, so now that I have this, I need to do something. Okay, let's start at the beginning. Partial V over partial F. May I rewrite this as partial V over partial F, partial U over partial U? Which then may I rewrite this as partial V over partial U by rearranging partial U over partial F. So we did this equation last time. Can you guys look up this equation last time we did this? Between 1A, 1B, 1C, 2s, and 3s. It could be flipped though. The U's and the V's could be inverted.
You want to look right now?
Oh, what's the answer? I think it's 2B. Look for equation 2B.
It should be partial U or partial V, do later B.
Yeah.
But that's
So that's partial V over partial U. So what will be the answer?
1 over negative B.
That's it. So from equation 2B, may I write partial U over partial V equals negative P? So can I write this as negative 1 over P?
Mm-hmm.
Yeah? Okay, so what's the unit for delta U? Is it energy? What's the unit for energy? What's F? It's also energy? What should the units for F be? So there's joules over joules? What's the answer? Do we see that? Energy over energy is 1. So we will get 1 over P. Okay, number 2. Step 2. Nick, you look confused.
Yeah.
What?
So like U and F are both energies.
Yep.
But like how does that mean it's just one?
So the units.
Can it just be like any constant though?
No, it'll be 1. I mean, it could be, but I don't care about constants right now. they'll take care of themselves once we start plugging in numbers. But there will be like a numerical number, but that numerical number will pop up once I'm more concerned about the big equations. So yes, F equals MA. There is going to be values of M. There is going to be values of A. Yes, all forces will be different. But when you're writing F equals MA, you only are worrying about the dimensions. You don't worry about actual numbers. Yes, there will be a number that pops up. But when you're developing the equation, you don't care about those details. Right? Good question, but yes. Okay, next one. I'm worried about partial V over partial T. Again, may I write this as delta partial U over partial U? Or partial V over partial U and partial U over partial T? What is partial V over partial U? Equation 2B tells me what? Negative 1 over P. And is there an equation that can help me with partial U over partial T? It is a constant volume. What does my second law of thermodynamics say? So what was my definition of S? Entropy. dQ over T. Or for constant volumes, du over T. So may I just simply write this as S? Can I do that? Can I do that? Can I do that? Or negative S over P. Excellent. Now what's my last one that's left? Partial V over partial N. What can I do to this? I have another equation. Hold on. V over partial N, partial S over partial S. Can I write this as partial S over partial N? Ooh. Is there an equation or two that can help me here? Okay. Going back to my equations, what am I looking for? Partial V over partial S.
It'd be T over B, or T over B.
T over B. What equation was that?
1B.
1B. This was 1B. And do I have an answer for this one? (3C)? Yeah? Which one do you want? 3C?
They're both the same.
They're both the same. I'll pick 3C. But you said 1C also works?
They're both the exact same.
Or 1C works. So what will I get? Minus T over P and minus mu over T or mu over P. Which gives me what? And then I can plug all of these into the above equation to give me into this equation to give me dV equals negative 1 over P dF plus negative S over P dt plus mu over P dN. All of these terms are being divided by P. May I move that to the other side? What will I get? PdV equals negative dF, negative S dt plus mu dN. Or dF equals PdV negative S dt plus mu dN. Minus. That's the thermodynamical identity.